In a previous video, we discussed the power and torque requirements we have for our motor. I want to show you some motors and their specification sheets, also known as data sheets. I didn't have a particular application in mind. I bought them from typical sources that you may use. Then I basically played with them, did tests with them to get a better understanding of their performance. Here's 3 motors that I bought. This one is from eBay, it came from China. I call it the eBay motor, and I bought 3 of them for €4.56 with free post. The next one I got on Amazon, 8 of them for €11.30, again with free post with Amazon Prime, so a fairly sweet deal. I call this one the Yellow Hobby motor. The last one I sourced at Farnell, an Irish-based supplier like Radionics. I got 2 of them for $15.50. Plus post of €5. I call this the Farnell motor. Next we look at the websites and I'll show you where to find the spec/data sheets for these motors. So here we have our motor from eBay. A bit of information about the voltages. We need to scroll down a bit to try and find a bit more detail and specification. So you've got to search around for these things. So we come down here. Okay, what have we got? We've got motor height, we've got an output shaft diameter 2.05, that's useful. We've got the voltage range, and we've also got speeds at the speeds of the output at different voltages, but no information about torque. Okay, this is the Yellow Hobby motor, as I like to call it. You can see it's currently unavailable. It's available on eBay, lots of sources. Not a whole lot of information there, as you can see. Tells you the voltage range. Scroll down a bit, try and look for a spec sheet. We see at the end here, not a whole lot. Voltage range gives you the gear ratio, so not much information on that. Now I have a little bit more that I found. Lastly, we have here our Farnell motor. We can see we have some detail on the voltage, the torque output in grams, centimeters, and the wattage. So if we look around and try and find some more detail, we might click on this data sheet little thing here. And that just gives us a diagram of the motor itself, which is no good to anyone. So we want to search around. We still have some information down here called technical data sheets. This brings us down to a little bit more information. Now I got a more detailed data spec sheet, but it went directly to the manufacturer, and I'll show you that later. So let's look at these spec sheets in a bit more detail. First up, we have the eBay motor. We get some details about the physical size of the motor, the voltage range, and the low load speed at different voltages. No information here about power or torque. I did some speeds tests myself and found that at 12 volts we get 5,000 RPM, up to 24 volts we get 12,000 RPM. So these don't correlate very well with the speeds given. I also did some tests with this motor and the gearbox and found the current draw under load at 12 volts to be 0.1 amps. So an electrical power of 1.2 watts. One piece of information that is given that is important is the output shaft diameter of 2.05 millimeters. This is important if you want to attach a coupling or gear to it. Next we have the Yellow Hobby motor. Very little useful information here. The yellow part houses a gearbox which according to the spec has a speed reduction of 1 in 48. It gives a power rating of 0.1 horsepower, which I've converted to 75 watts. Now this is kind of dodgy enough getting a power rating and horsepower at number 1, but this 75 watts is impossible given that a load current of 0.150 amps at a voltage of 6 would give an electrical power rating of 0.9 watts, and there's no torque information. I played around with this motor gearbox a lot and found that the maximum electrical power was 1.2 watts, the maximum torque was 150 grams centimeters, and the mechanical power was about 0.07 watts. The speed of the output was around 100 RPM. I will be doing a separate video to show you to determine the speed of the motor output shaft and also how to find the torque and mechanical power. Finally, the Farnell motor. We get a lot more detail here, a power rating, speed and max torque. Again, the shaft diameter of 2.3 millimeters is given, but the information is all over the place. The power rating will most definitely be electrical input power and not the mechanical output power you can expect. It gives speeds, but at what voltage? The torque rating is given, but it doesn't tell me what speed this is for. I did some tests with this motor too. Again, the no load speeds were at 6 volts 1875 up to 14 volts 6666 RPM. By the way, no load speed is when there's no load on the output shaft. It's just spinning freely. There's nothing attached to it. It's not driving anything or lifting anything. Again, you can see these speeds don't correlate well with the information given. I found the maximum electrical power to be 7 watts and the maximum torque to be 54 grams centimeters, which is at least closer to 65 grams centimeters as given on the data sheet. The maximum mechanical power I got was 0.1 watts, which if we compare it to the spec sheet power of 5.6, gives a very poor efficiency of 1.7%. Conclusion is that motors are tricky things to buy and get right. So cheap in general will not work unless your power requirements are quite small. It is unlikely that you're going to find a motor that exactly matches up with your torque or power requirements, and some form of gearbox will be necessary. I will be looking at gearboxes in another video. Where do we source a decent motor with a proper spec sheet? Here are 3 from Adionics. They do have proper spec sheets, and you can see there's variation in speeds and torques available. And this one is from Wish. Hey, if it can power an electric scooter, it should be powerful for anything we need to do. Okay, these are couplings for a motor. So the idea is they will fit onto the output shaft of the motor, and then you can attach another drive shaft here something that you're turning. Okay, so they come with kind of different size there and different size there. This happens to fit onto this one quite neatly. You can drill them out maybe to size, but you're really looking for a coupling that exactly fits your motor. This is another type of more universal coupling. You can see it's got different hole sizes. So that's a coupling. You're going to need one if you want to attach something to your motor. Okay, unless you're going directly onto a gear. So that's a motor coupling.